This thing is not telling me that our class is recording. Okay, so nobody has one that was particularly difficult. Y'all all think it was easy? Okay, so then maybe we'll do this. Ethan, pick one from number 1 and show us how to do it.
I guess we'll just go with the first one.
Okay, so 1a, sine x equals root 3 over 2. We're solving for x on the domain from negative 360 to positive 360. Okay, so what do we do first?
Basically what I did was I took the inverse sine of square root of 3 over 2.
Okay, so we're looking for the x's that satisfy this. Okay?
Yeah.
In other words, we're looking for the y value of an angle that satisfies this equation. Okay? So what did you do then? Ethan?
I put it in my calculator.
So in your book, it says calculator inactive. So now what did you do?
Well, I can also look at your unit circle.
Okay, let me pull up our unit
X value.
Okay, so what would you do looking at your unit circle?
You would go to where the y value is square root of 3 over 2 and look at the x value.
Since we have a domain that's in degrees, our answer needs to be in degrees. Okay, in number 2, because the domain is in radians, your answer needs to be in radians. So what degree measures have positive root 3 over 2 as the y value?
60 and 120.
Okay, so x could equal 60 and 120. Are those within our domain?
Yes.
Are those all of the possible solutions in our domain?
I think so.
So let's think about our domain for a second, okay? So here is our axes for our unit circle, okay? We're starting at negative 360. Negative 360 happens, so positive angle measures go in the counterclockwise direction, correct?
Yeah.
Okay, clockwise is going to be negative angle measures. So if we started at negative 360, that means we're at the angle that went all the way around clockwise to this point. So we're starting at this point. We have to remember that we went all the way around in this direction, right? So as we go in the correct direction from negative 360, we're going to hit negative 270, negative 180, negative 90, and then go back to 0, right?
Right.
Do we pass the places where our angle measures have a y value of root 3 over 2 along that way?
Yeah.
And what angle measures would those be?
That would be
so this, think about it this way. This is 60 degrees from 0, right?
Right.
So it's also 60 degrees from negative 360.
So it would just be negative 300.
Yeah, so negative 300 works. And what about this guy over here?
Negative 240.
Yeah, negative 240. Okay, so when we start at negative 360, we go around, we hit negative 300, negative 240, and then we don't hit any of our solutions until we go start at 0 again. So we've gone negative 360 degrees. We've gone up to 60, up to 120, and then go all the way back around, and we end up at positive 360, finish out our domain, and we have 4 total solutions for this particular domain. Okay, Ethan, how do you feel about that now?
A lot better.
Okay, good. Great. So if we did not have a domain, if the domain for some reason was all real numbers, how many solutions will we have? I'll open this up to anybody. So if we could have any angle measure.
It would just be infinite because you can keep adding 360.
Good. And so you would write it in terms of multiples of 60, okay? And so you'd have like a variable that would produce each of these each time you subbed in the variable. It likely will not ask for that. It will likely only have a specific domain that you have a finite number of solutions on. So in this particular domain, we have 4 solutions. Are there questions before we move on to number 2? Okay, if there are no questions, no, I lost all my popsicles. I guess I'll call on somebody else. Imani, will you pick one in number 2 that confused you?
Let me check. Part D.
Okay, so we'll do 2D. Okay. All right, so 2D gives us that the sine of theta is -1, okay? And the domain here is from -2 pi to 2 pi. We typically use theta when we're in radian mode, x when we're in degree mode. They're just a variable though, that's all that it means. Okay, so when we look at this, we need to look at values on the unit circle where the sign is -1. Let's see, Kimberly, can you tell me what values on the unit circle have a sign value of -1? So if I drew out a circle, where would the y value be -1?
Like in radians?
Sure, that's fine.
3 pi over 2.
Right, so we're at -1 right here. Okay, but our domain starts at -2 pi and is going to go, so it starts here at -2 pi and it's going to go all the way around. So this is going to be a negative angle value when I hit it first, right? So I started at -2 pi and then I'm going positive 3 pi over 2 radians to get to this spot. So can anybody tell me what angle measure this should be?
Like -1/2 pi.
Yes, good, -pi over 2. Okay, so I'm going to have a theta measurement at -pi over 2. Okay, then I'm going to pass that and I get all the way back up to here and I'm at 0 again. Okay, so then I start my positive domain values and I go all the way around and now I've gotten positive 3 pi over 2. Okay, 3 pi over 2. All right, and now I can finish out my domain and end at positive 2 pi. And once I have done that, have I completed my domain? Alston, have I gone all the way through my domain?
My screen's frozen.
I can't see.
Well, nothing's moving on the screen right now, so
Now.
no. So no. So what do we have left to do? So if we start at negative 2 pi, we went all the way around, and we hit our first point at negative pi over 2. We finished out the part of our negative domain, then started our positive part of our domain, hit positive 3 pi over 2, and then finished it out. Have we gotten all the way through our domain?
Yes.
Yes. Okay, so we have 2 total solutions for this particular problem because we only have one place on the unit circle where that measurement occurs. What questions do you guys have? Okay, do you guys want to redo this homework? Or would you like me to go through and grade it as is?
Let's redo it.
Okay, so I'm gonna give you guys the same exact homework tonight. And I opened up the previous assignment. So the homework for, I think it was 923. So what you can do during your asynchronous assignments is you can just click on this hyperlink and it takes you right back to the homework from 923, okay? And just resubmit here. So you should have 2 total submissions for this particular assignment. What was I gonna say? So on today's activities, there will not be a place for you to turn in homework. Does everybody understand that? So if you look at today, the 28th, there's only activity 1. There's literally nothing to turn in on this date. You will return in your homework on the 23rd, on that particular date on Canvas. All right, does that make sense?
Yeah.
Okay, good. All right, so today we are going to go through some more trig function stuff. We're going to do an investigation. We're going to start it together. Normally, if we were in class, you would do this on your own, and I would just kind of walk around the room and help you out. So your investigation is kind of going to function as notes. So I'm not going to have you turn it in. We're going to put some vocab on the back. And you guys can use Desmos to complete this investigation, and the investigation is listed right here if you want to print it out. Before we go ahead and start this, if you have access to a printer and you want to take the time to print it out, you can go ahead and start doing that. I'm going to show you guys a little demonstration. Normally, I have it's this really cool lab activity where you take your unit circle that we made the other day, and you basically take spaghetti, dry spaghetti, and you break off the spaghetti pieces to get all the X and Y value linked. And then you tape them onto a sine and cosine graph. Hold on, there's somebody trying to get in. And so we normally would do that. I felt like that was maybe too complicated for us to try to do, and maybe not as effective in learning and teaching. So we're just going to go ahead and start with this investigation. So to kind of replace the spaghetti trig activity, I'm going to show you guys a little demo to show you how the unit circle basically traces out the sine and cosine graphs. So we'll start with sine, okay? And I want my sine graph to start here. And then let's see, where is my trace? Oh, start. Trace on. So if we start, I guess normally we would start at 0. Hold on, let me turn this trace off. So normally we would start at 0 degrees, right? Okay, let's turn our trace back on. And we would take it and we would travel all